So, assalamu alaikum, everybody, and thank you for joining us again. This is the second lecture in a 4-lecture series by Dr. Mir Faizal, hosted by Al-Mawrid Institute Canada, where we are inviting special guests to address important issues for Muslim youth. And basically, while the overall series is related to topics of God, reality, and science, the first lecture discussed defining God as the most fundamental aspect of reality and dealt also with nature of issues with respect to language. And now this is the second lecture, which deals with design and creationism. Again, Dr. Mir Faizal is an eminent physicist who is a director of the Canadian Quantum Research Centre and has affiliations with the University of Lethbridge and the University of British Columbia, Okanagan. He has published broadly with over 150 publications, mostly focused on quantum gravity, which has to do with integrating ideas of general relativity and quantum mechanics. As a devout Muslim, he has pondered very deeply throughout his career ideas of trying to reconcile his faith and theology with his field of expertise. And he'll be sharing with us the second lecture in this series. So I'm very glad to have you here, Dr. Mir Faizal. You may begin.
Okay, so this lecture is about design beyond creationism. So I would clarify, creationism is wrong, design is correct. So let me clarify what I mean by that. You see, creationism is this theory of interventionism in which God intervenes. There are gaps in the evolutionary process and God just intervenes to fill those gaps. This is clearly wrong, but let's see why it's wrong and what we can learn from its mistakes. And if there is, and the central argument that the creationists are trying to make, if that has any validity. So the standard creationist argument starts with the biological complexity, with I being a prototype. So the idea goes like this, that I is so complex that evolutionary process is not enough to explain the formation of human eye, because it's so complicated, such a complex biological system. The problem with this argument is that evolution is enough to explain biological complexity. And as I'll show you after this slide, there are good amount of papers which are written on this. So evolution does explain biological complexity. The second part of creationist argument goes like, okay, maybe evolution of life we can explain by itself, but the abiogenesis, how life formed from beginning, we possibly can't get a grasp of it. Again, wrong. We have modern theories of abiogenesis, again not complete, but they give a fairly good understanding of how life could have evolved. For example, life could have evolved from self-replicating clay molecules. Life could have evolved from radioactive beaches. So they're very good. There's good number of research papers done on this. There's good amount of research done on it. And yes, like any field of research which is not complete, it needs more research. It does not need a god of gaps. There are again no gaps in the evolutionary process or in abiogenesis. Evolutionary process is enough to explain biological complexity. So first of all, get this right. Like the central premise of the creationist argument, which tries to show flaws in the evolutionary process, is wrong. Like any field of science, evolution needs more further research, and abiogenesis needs further research. But already we have made lots of breakthroughs, and especially human eye, we can pretty much explain how it evolved from evolution. In fact, there's this nice paper in Nature, and the next paper which is written about evolution of human eye and how human eye actually evolved can be explained really nicely from an evolutionary perspective. And the last three papers are just few papers I could find, or like few papers I decided to cite in a huge body of literature that already exists about abiogenesis. Not that I could find that, I just decided to cite them. So there's a huge body of literature discussing abiogenesis, which is a field in itself. So to say that, well, we need a god of gaps, no, we don't. We have pretty much, we have started getting good understanding of how abiogenesis could have occurred, and we have a fairly good understanding of how complex structures, including the human eye, which is discussed in the first two papers, can be explained through evolution. But let us really analyze what the creationists, despite being wrong, were trying to say. And what does it really mean to say that because human eye is so complex that you really need God or intelligence behind it? Well, let's try to formulate this argument in a more consistent way. Then that way we can make some progress. What this really means is this: that if there's a computer programmer and he's simulating things and he simulates an eye on a computer, then what you can basically you can say that this programmer is really intelligent, because this is a really complicated system that he has been able to simulate on a computer. So the fact that you would need a lot of intelligence to simulate an eye on a computer means that if you see a structure like eye, this needs intelligence, even on a computer, even as a simulation on a computer. But now even though creationist argument is wrong, let's see this fundamental argument from design that is being made. It certainly needs intelligence to simulate eye on a computer. But let's focus only on a computer program. Then we'll make a mapping to reality later on. So certainly it needs high amount of intelligence to simulate eye on a computer, but it needs even higher intelligence to simulate a whole evolutionary process leading to the formation of eye. It's easier to simulate an eye. It's really hard to simulate a full evolutionary process that will lead to the formation of eye. And now think about this, how difficult it would be to simulate right laws of chemistry leading to the evolutionary process on planets, leading to formation of complex structure. It would need extremely high amount of intelligence. Think about this now, how difficult it is to simulate the right laws of physics, which would lead to the formation of planets, which would lead to right laws of chemistry on those planets, which would lead to the evolutionary process simulating an eye. And think about this, how difficult is this to simulate the correct bit, producing the correct it, which has correct laws of physics describing it, which produces correct laws of chemistry, which produces an evolutionary process, which produces biological complexity on various planets in this universe. This would need huge amount of intelligence if you're just trying to simulate this on a computer. So you can see that, if you just see what the central argument that is being made, that yes, you need intelligence for biological complexity, but that is the evolution doesn't diminish it. Evolution enhances this argument of design, and chemistry doesn't diminish evolution, it enhances it. You see, there is structure upon structure. There is not structure upon darkness. You can see this hierarchy of structures with biological complexity just being enhanced by these other structures in the universe. So there is no God of gaps. There are no gaps. There is a God who left no gaps in the universe. The God is so perfect that there are no gaps in the universe. And I do not know why gaps equal imperfection should equal to God. The fact that there are no gaps and you have this hyper consistent structure of reality shows hyper intelligence behind it. And this is in fact a stronger argument for God. So don't try to search for God in gaps. Look at the beauty of universe, which has no gaps, and that points to the beauty of design. So yeah, so I think the whole argument of design is correct, but the way creationist approach it is wrong. Evolution enhances design, doesn't diminish it. So that is the point one I want to make. And again, something really important, and this is what many people make a mistake. We are talking of biological complexity, not biological utopia. There is no biological utopia. Everybody knows there is suffering. In fact, I don't know why people started looking for biological utopia. All major religions and philosophies on earth that I know of at least agree to biological suffering on earth, and nobody is talking of a biological utopia on earth. So in fact, I would go one step further and say that suffering is programmed. You see, most unicellular organisms that early life comprised of did not age. Aging, suffering, and death resulting from that suffering of aging was programmed as an additional layer of programming into the biological systems, which might be, and this programming might be as complex as I itself. So this idea of aging is a very complex procedure which has been programmed into us. And it might be, as I said, it might be even more complex or possibly as complex as I. And it did come as an additional layer of programming, because you can see that cellular organisms did not age at all. So aging, suffering from that aging and death was actually added on as an additional layer of programming into us. Because if single-celled organisms, which are the early form of life, aged, then in a couple of generations, life would go away, right? They just reproduce by splitting apart. So you can see that aging and all this suffering was actually programmed in a way into us as an additional layer of programming, and this might be as complex as the eye itself. Again, through an evolutionary process, the same argument of it being simulated on a computer. So it would be harder to simulate life on a computer which ages than life which does not age. So yeah, there is no biological utopia, and suffering is added as an additional layer of programming. How do you make sense of suffering is an entirely different question, and that's a question we should answer. But one thing that we should note is that suffering does not equal flaws. In fact, suffering is deliberately put in as an additional layer of programming. Another thing to note is that suffering and pleasure is bounded in our in our universe. For example, if you suffer, if you have pain beyond a certain level, you just die from a neurogenic shock. And if you're living a hedonistic lifestyle and you just start enjoying a little, then your pleasure center just blows up. And so yeah, so suffering and then you bring pleasure due to gradients of what you're experiencing. So both suffering and both suffering and pleasure come due to an additional layer of programming. And the way you make sense of it, for example, in various religions and philosophies, is to, for example, one way of making sense of it is that you need at least this finite bounded set of pleasure and pain to make sense of morality for complex life, so you can choose between good and bad. And there are, interestingly, different religious philosophies that approach this question differently. But the most important take here is that the absence of biological utopia does not mean absence of structure. In fact, nobody is arguing for biological utopia. And the final thing that we have to realize is, because sometimes people become emotional and say, oh, so many people have died, that final outcome of life on this planet is death. Whether you die from aging, you die from accident, you die from a heart attack, you die from X, you die from Y, there is death. So yeah, so we shouldn't become super, like, we have to understand meaning of life within that context, but not say that, oh, because so many people died due to an X accident, that means absence of structure. No, it doesn't. It just means death is a part of life and we have to make sense of it. So yeah, so this is very, very important. Sometimes people bring this up. I thought I'll cite some papers here. So what were on, yeah. So the first, so the first few papers are, I guess, about how aging is there. Aging is there, has been added on and as an additional layer of programming. The second, so these are the first layers of papers, how aging has been added as an additional layer of programming into the structure of life. So aging, and so if nothing else, you die from aging, which of course leads to suffering and death at the end of the day, but it has been added on as an additional layer of programming. The second few papers are about neurogenic shock. If you suffer a lot of pain, you die from a neurogenic shock. And the last few papers are about, if you have an extremely hedonistic lifestyle, how your pleasure center just blows up and you stop feeling pleasure. So you can see that life is a bounded set of pleasure and pain, in which death has been really programmed in as another level of complexity. Now, I want to come to multiverse, because sometimes people argue, well, maybe you can do away with design in a multiverse. So there are many models of multiverse I want to talk about before we can address this question. So the first model of multiverse, which I would call philosophical multiverse, something I'm really against, even though not because of this particular argument. The particular argument would hold for it, but I don't even think that's science. It is this many world interpretation of quantum mechanics. So the idea is that as soon as you do something, the universe splits into two, in which in one of the universes you have done it, and in another of the universe you have not done it. All the possibilities are actualized, and it's just in different universes they are actualized. This is really not really right. I don't think anybody really takes it seriously also, because even the proponents of many world interpretation would not shoot themselves, because in some of the universe they are alive. Even they know this, like, this is not supposed to be taken seriously. And it was an old model of quantum mechanics, an old model to explain measurement problem in quantum mechanics, along with the Copenhagen interpretation. But there has been a long, the the measurement problem in quantum mechanics has gone way past these interpretations. And now we have really new models of quantum mechanics describing measurement, trying to address measurement problem like collapse model and decoherence. And they're way better at explaining measurement problem than these old models. But anyway, for completeness, I thought I will include the many world interpretation of quantum mechanics here. Then there is the idea of multiverse as patches of observable universe. See, in our universe, we don't observe all of the universe. We observe a section of the universe called the observable universe, which is limited by the velocity of light. So we, since nothing can travel faster than light, we can be causally only related to a part of the universe, and that causal patch which of universe that we are related to is called the observable universe. But then every different observer in different galaxies in different parts of the universe will have their own causal patch, and these different causal patches would form different observable universes corresponding to these to these observers. And in this sense, this is almost I would call it a trivial multiverse, because such a multiverse certainly exists. I mean, we have our own causal patch, and every other observer in any other galaxy would have their own causal patch, and that's fine. And our universe would be broken into many of these causal patches. And then we have brains in extra dimensions. You see, in M theory, we have 7 extra dimensions, and our universe can exist as a brain in these extra dimensions, as a sheet in these extra dimensions. But then you can have multi-sheets, many brains parallel to each other, and these could act as parallel universes. And interestingly, this model of multiverse can actually be tested. So you can, if this model of multiverse is true, you should be able to create mini black holes at some point in a large hydron, in a particle physics experiment. And so this model of multiverse can actually be tested. And then you have the landscape, another landscape multiverse. So what happens is that this is a model in which you assume these extra dimensions in M theory, 7 extra dimensions in M theory, or if you want to reduce M theory to string theory, then 10 extra dimensions in superstring theories. They are really small. They're so small that you can't detect them in our particle physics experiments. But then there are lots of ways of doing it. Some estimates have suggested 10 to the power 500. That's 10 with 500 zeros after it. Possible ways of doing it. And then the question is, why only one of those has actualized? Then one way of answering it is that no, all of them have actualized. We just happen to live in one of them. So you have this huge number of universes produced as a whole landscape of universes with different physics in this M theory scenario. Again, if you go to inflation, I already told you that in my previous lecture, how universe can be created out of nothing from inflation. But if it can be done once, it can be done over and over again and again. Again, you have a multiverse which would occur in inflation. And finally, you would have a multiverse that would occur in an abstract mathematical setting of third quantization. Just in third quantization, you start from this abstract nothingness, which is called a third quantized vacuum state, do mathematical manipulations on it, and you get a multiverse. And in a fourth quantized setting, you can actually have a more general structure than a multiverse. You can have a multiverse. Again, you can do these abstract manipulations on this fourth quantized vacuum state, which is even a more abstract nothing, and get a multiverse. And I thought I'll cite some papers on it. So the first paper is on the collapse model. The second is on the decoherence model. Then there is the observable universe. Then there are some other paper on inflationary multiverses. And then there are papers on third quantized, fourth quantized multiverses. What other multiverses did I talk about? Yeah. And then there's this paper, 2019, it's about this landscape, and before that there is this paper on brain world multiverses. So all these multiverses I have talked about are very well discussed in physics literature, and these are some really nice citations if anyone wants to look at it. Let's come to one thing. The physics in multiverse can vary, and this is sometimes taken as an argument against design. Oh, we have varying physics, so our physics in the universe is like it just comes out of multiverse. But please understand, like it's important to understand that physics of each universe is produced from multiverse, is produced as an approximation from some physics which operates in the multiverse. So there's a grand structure which operates in the multiverse, and as a substructure to that grand structure is an approximation to that grand structure. You have an approximation in our universe. It's no different from the way other approximations work, like the way the physics at our scale emerges from atomic physics. Physics of a specific universe emerges from a larger physical, more elegant mathematical structure of the multiverse. Now, it's important to note in all these models of multiverse that I have cited, including multiverse, there is a super elegant structure. There is even a more elegant structure or mathematical structure operating in multiverse, which approximates to some physical structure in our universe. So multiverse again doesn't diminish the physics of our universe. It enhances the structure. There's a more beautiful, more elegant mathematical structure operating in multiverse, which in some approximation reduces to the physics of our universe. Another important thing to note is that multiverse exists at the level of it. Even multiverse exists at the level of it, not at the level of bit. So even multiverse or multiverse is produced from an abstract bit, an abstract physical law produces all this, not vice versa. So even multiverse or multiverse exists at the level of bit. No, sorry, exists at the level of it, not bit, and it is produced from some right bit. And it is not possible to construct any consistent model of multiverse without pre-assuming a mathematical structure producing it. What would you produce it from? So you have to assume an elegant bit, an elegant axiomatic mathematical structure which can give rise to multiverse. So definitely, so the multiverse doesn't diminish from design, it again enhances it. You can again, in fact, these are few papers where you can see how the physics of our universe emerges from the physics of multiverse in different scenarios. This is very, very well studied problem, but this is how almost all the models of not almost all the models of multiverse work. All the models of multiverse are based on a more sophisticated structure which approximates to the physics of our universe as a limiting structure. Now, we can really reiterate the argument we used for for the multiverse. It would be difficult to simulate our universe with its laws of physics on a computer, but it would be even more difficult to simulate it would be difficult, let's put it like this, it would be difficult to simulate our universe on a computer. It would be even more difficult to simulate laws of physics producing our universe on a computer, but it would be even more difficult to simulate a multiverse on a computer, and it would be super difficult to simulate the right laws of physics which would produce these multiverse, which would produce various universes with the right laws of physics, and some of these universes would have the intelligent life on a computer. This would require super duper intelligence. This would require a lot more intelligence than simulating just a single universe or simulating an eye. So you can see that multiverse doesn't diminish design, it enhances it. And now think about this. How difficult would it be to produce to simulate just the right bit, which would produce the right it, which would produce the multiverse, in which would produce different universes as different approximations of that grand structure of multiverse. And in these different structure, these universes, you would have different in some of these universes, you would have intelligent life, which would be a complex structure. You can see how much intelligence it would require to simulate this on a computer. So you can again see there is no God of gaps. There is a God who left no gaps, and there is this hyper structure to reality, hyper intelligent design to reality, hyper structure, how hyper beautiful structure to reality. But then we come to an interesting question: what if this universe is a simulation? The argument would still hold, you see, because the aliens who simulate us would be complex, would need to be complex enough to be able to simulate us. So they would be living in a complex universe, and then they would need so that so then in that complex universe life could form, and then they would be able to simulate us. So the aliens living in that universe who simulate us, the argument will go on and apply to the universe of that alien. The same argument will apply to the universe in which those aliens live. And even if there's an infinite regress of these aliens, the argument would still hold, because then you would use the concept of limit and arrive at the first universe from which this infinite regress occurs, and then apply the argument there. So the argument would apply to nevertheless. So it might be difficult to argue for our reality, but the argument of design holds irrespective of whether we are real or not. Even if the universe is a simulation, the argument of design still holds. There is still God. There's still design in the universe, and it just would apply to the alien simulating us, and this doesn't change even if there's an infinite regress. Finally, I would come to something interesting. What would a universe like we have mentioned, like we've seen how how corresponding to our universe, our reality, there is design. What would be a universe where there is less intelligence? You see, the problem here is that our human mind finds it difficult to understand zero or infinite. And so it's really difficult to think of a universe with zero intelligence. But let's think of a universe with less intelligence. How would you know that a programmer is not really intelligent if you see a certain simulation made by this programmer? A simulation made by a programmer which is not that intelligent, and he's trying to simulate the universe, he or she would simulate a universe with very simple structures, very simple laws, maybe something like a Lego universe in which blocks just add up and make more complicated structure, like more complicated blocks, some very simple structure. If you did see the simple structure, then you could say, well, there's not much of an intelligence behind it. And zero intelligence would be the simplest of structures, possibly absence of structure, which is very difficult to conceive of or think of. And that's why people get confused in thinking of the structure. But let's just think about it. Let's regulate it. We use this term in physics. We set some epsilon, which we can later on take to zero. That's regulated by a small intelligence. And you can already see what a small intelligence would imply to would produce a simple universe. Is our universe simple? Certainly not. I mean, I'll just tell you a few things that we know about our universe. This geometry of space and time is described by something called Riemannian geometry, which is described by, according to general theory of relativity, and that's a fairly complicated geometry. The nature at small scales is described by even a more complicated theory, and that is quantum mechanics. Quantum mechanics has elegant structures like entanglement. Two particles which are really separate away from each other still obey the same, like are somehow connected, and they are basically the part of the same system, because of which you have even more elegant phenomena like retrocausality. You can set up experiments, and this has actually been experimentally tested, where you can do something in future which affects things in past. And it all depends on how you observe it and you know your knowledge of the system. And it's described by a fairly complicated mathematical structure. The standard model particles are described by a even more complicated structure, or if not more, at least a fairly complicated structure called gauge theories, in which you basically analyze rotations in something called an imaginary, you construct a geometry using imaginary numbers. You have this imaginary geometry, which is not the geometry of our space and time, this internal space, and you analyze rotations in that, and this corresponds to the way actual fields in nature behave. Why should that be? But no, it is. And the mass is generated by, again, a very sophisticated mathematical procedure called gauge symmetry breaking. So why should all these, so you can already see that our universe is described by a really complicated mathematical structure, far from a Lego universe, which you would expect from a very simple, far from which you would expect to be produced by less intelligence. So it does show that our universe has very high level of intelligence behind it. I thought I'll cite some references if you want to read about general relativity and special relativity. This is a good reference about then there's this really nice reference about gauge theories, and then which would include spontaneous symmetry breaking. And the last two papers are about retrocausality, how causality can act, how retrospectively you can set up experiments in future which can affect your past. So reversing cause and effect, which can happen quantum mechanically. And I would go one step beyond that, and I would say that, you see, the belief in the existence of such a mathematical structure, even when it's not discovered, without a proof, is the basis on which science is made. It's a very strong statement, but hear me out on this. So, for example, Newton's laws of gravity were known to explain the planetary motion of all planets. And then it was discovered that Mercury doesn't obey these laws. You could say, well, why should every planet obey these laws of gravity? Maybe when the system becomes too complicated, nature doesn't know how to compute, and with them, Mercury is just one of those exceptions. These laws only obey approximately, and when the system becomes complicated, you get a flaw in nature. Why should nature be described by a mathematical law in the first place? But if you take that approach, then there is no more science to be done. But the belief that even though we do not have the right law describing just one planet, some aspect of, like the motion of Mercury completely, means that that the law we are using is an approximation to something more elegant, a more beautiful law of nature, of which this law that we had is an approximation. A belief in the existence of such a law is the basis on which science is built. But look at it, before you discover such a law, you have no proof for the existence of such a law. You have no proof why nature should act completely mathematically. But the belief in the fact that nature does act completely mathematically, and if we do not know, if we are seeing an apparent inconsistency, it just means that the law we are using is an approximation to yet more fundamental, more elegant, more beautiful law, is the belief on which whole of the science, all science is built. And and especially when it came to Mercury, that turned out to be the case. When you had Einstein's general theory of relativity, it did explain the motion of Mercury, and did reduce to Newton's law in the approximation in which Newton's law was known to be producing correct results. Go one step further, the standard model particle. The standard model of particle physics is a model with lots of free parameters. Almost every single theoretical physicist that I have talked to thinks that it's an effective field theory. It comes from yet more fundamental, more elegant theory. But why do they think that? Is there an experimental reason for it? No. What is the reason that they think that standard model is actually coming from a more elegant theory in nature? The only reason is because it's not beautiful enough. There are lots and lots of these free parameters which seem to be randomly chosen. It doesn't seem really elegant enough. But why should universe be described by an elegant, beautiful mathematical system? There is no reason. But you can see this is how science works. That's what you want to believe, that it is always explained by an elegant, more beautiful mathematical system. And the fact, and people are working on it. They're spending their career trying to build standard model from a more fundamental theory of physics, in which these arbitrary parameters would be explained in a consistent way from one or maybe no free parameter. But again, you can see that the only reason why people believe that to be the case is because they think this theory isn't elegant enough. So you can already see that you are, even if you're not linguistically stating it, you are accepting design in physics. In fact, whole of the journey of science is to find design. Take another example of cosmological constant. You see, universe is expanding with an accelerated rate of expansion, and that is controlled by something called a cosmological constant. It has a very small value. And people have spent their whole career trying to find a mechanism by which you would produce such a small cosmological constant. But look at this, if you accept one of these elegant mechanism producing, and they haven't been able to, by the way, till now, the research is still going on. But look at this, if you accept one of these mechanisms producing a small cosmological constant, how many new things are you accepting? One. And if you just assume a small value of cosmological constant randomly chosen, how many new things are you accepting? One. So what makes you work and think that it should be possibility one, where an elegant mechanism produces a small cosmological constant, rather than two, where the cosmological constant is just set to its present value randomly? It is the subconscious belief that the universe has to be described by an elegant, beautiful, consistent mathematical structure. Otherwise, you are at the end of the day just accepting one more thing. And why couldn't that just be a small value of the cosmological constant? So I thought, based on these, this is some of the like the early work of Einstein, where he showed how general theory of relativity predicts the correct motion of Mercury. And then there's this work on standard model being an effective field theory. And then there are these series of papers I quoted in the end, where you can see, if you want to see what kind of sophisticated mechanisms people are talking about when they're trying to show why the cosmological constant is small. But the only reason why they are choosing this mechanism is because they feel uncomfortable in arbitrarily choosing the value of cosmological constant to be small, because it seems that there has to be some design behind it. I would even go one step further and say that all the major discoveries in physics rely on the idea of mathematical beauty. So when Dirac equation came up, it came up because Dirac was trying to reconcile general relativity and special relativity with quantum mechanics in a mathematically elegant theory, and ended up writing the Dirac equation, which predicted the existence of antimatter, and then antimatter was discovered. So it was just mathematical elegance which produced Dirac equation, which predicted antimatter. Young-Mills theories, which describe the fundamental forces of standard model, were again constructed because of mathematical elegance. Special and general relativity, especially general relativity, was just constructed to be a mathematically elegant theory, and then all the other phenomena were discovered. But I would go one step further. Possibly the top 10 physicists, or the most researched branch in which most physicists are spending their time, is supersymmetry. But we do not have a single experimental proof of supersymmetry. So why are people working on supersymmetry? Why are the maybe top 10, 20 physicists working on supersymmetry? Why are people spending their life working on aspects of supersymmetry when there is no proof of supersymmetry in any particle physics experiment? It's just because it's mathematically elegant, and it's so elegant they feel it should be real. The same thing holds true for string theory. There's no proof of string theory, but just because it's mathematically beautiful, they feel it has to be real. The same thing holds true for any other approach to quantum gravity. So you can see things like string theory, supersymmetry, and many different approaches to quantum gravity. The only reason why people spend their life working on it is because of mathematical elegance, and because there is really no experimental proof of these things. So, for example, so I thought I will quote these things. If you want to read about Dirac equation, this is a nice paper. This is a nice book, sorry. And then about gauge theories, this is another nice book. This is another nice book about spatial and general theory of relativity. And the next one is about supersymmetry, and the last one is about string theory. These are textbook materials. So I quoted some few textbooks here, but if anyone wants to read it and see what elegant structures we have in it. Finally, one thing, it's important to realize that not all beautiful mathematical structures are actualized in our nature. So some of these theories we're working on might not actualize in our nature, in our universe. But all structures that actualize are described by mathematically elegant structures. So not every mathematical elegant structure corresponds to something which is real in our universe, but everything that is real in our universe corresponds to some elegant mathematical structure. Our universe, and even this extends to multiverse, is described by an elegant mathematical structure. And this is what has motivated research into supersymmetry, string theory, quantum gravity, and all the fundamental laws of theoretical physics. It is the belief in this consistent mathematical elegant structures. But now let's come to this. So I will reiterate, belief in consistency and elegance of the laws of physics describing nature is what has led to development of theoretical physics, is at the foundation. Is what has led to major developments in answering the fundamental, in understanding the fundamental laws of physics. But what motivates research into such a mathematical structure? Why should nature be described by such an elegant mathematical structure? Why should reality actualize such elegant mathematical structure? We just believe it without proof. And now look at this. What is an elegant mathematical structure? But it's just a complicated, really complex structure. And it was the existence of such complex structures that naive creationists were using for the argument of design. So even though the naive creationist argument is wrong, the argument of design isn't wrong. In fact, there is design upon design, structure upon structure, and universe is just described by a way more complex structure, way more complex design than what the naive creationists were trying to find. So that, in fact, I would even go further and say the design has never been absent. It has never been just linguistically identified correctly. Whole of the journey of theoretical physics is based on the idea of finding a design. Even when there is no proof, we just believe in its existence. And this is what has led to massive developments in science. So yeah, so this is the point I wanted to make here. So with that, we end this lecture.